Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. So, in this episode, we are going to talk about some ground truths in data science. And before we dig deeper into the ground truths, let's get some basics clear in our heads. So, for data, a population is a universe of possible data that you can have. Okay. And there are some attributes to that population. For example, there could be a population mean, population variance, population standard deviation. Those attributes of a population are called parameters of a population. And sample is basically a set of observations from that population. And then for sample, we can have same attributes such as sample mean, sample variance, sample standard deviation. And those are called statistics of a sample, or like one attribute is called statistic of a sample. So mean is a statistic of a sample, but mean is a parameter of a population. Okay. Now, the first ground truth: population parameters are not observed, but sample statistics are observed. What I mean by that is, you can observe, you can calculate sample statistics, but you always estimate the population parameters. You can't with any 100% certainty say that the population parameter is this and this. You can with 100% certainty say what the value of sample statistic is, but you can't say with 100% certainty what is the value of population parameter. Ground truth number 2: you are always working with a sample, but you are always interested in population. Okay. So population is this unachievable intangible entity that you would never be able to capture and do the data analysis on. In fact, it is impossible to do data analysis on population because it is infinite. It's like an ocean of data, and the sample is a drop in the ocean. So just like it is not, it is like you cannot count the number of objects in the universe. You can only count what you see in your frame of reference, and that frame of reference is your sample. Now, the situation here is, even though we cannot determine anything definite about the population, we always want to estimate parameters about the population. We are always interested in population. And that's why whatever we can do to make our estimates better for the population parameters, we do that. Even though if it means that we say our estimates are correct in some confidence interval and not necessarily completely correct, we say that. And mind you, the estimates for the calculation for population parameter is never going to be correct, because it is an infinite universe of data. Now, this estimate of population parameter can take many forms. So simplest estimate is mean, right? So there is a sample mean and there is a population mean. You calculate the sample mean, but you estimate the population mean. So for that, you say, I estimate the population mean with some confidence interval. Okay. Now, this is true for one dimensional data, right? So when you have one dimensional data or only one feature of data available, like in one episode, I talked about like heights of kids in one class. So if you just talk about heights of kids, you can calculate the sample mean if there are 20 kids, but then you are going to estimate the parameter of the population of kids and say that the for the population mean is going to be such and such with some confidence interval. Now, for multidimensional data, where variables are dependent on each other and you are trying to find correlations between variables, or in supervised learning methods you are trying to find some equation to predict a sample space. In that situation, now the equation itself becomes an estimation for the population, right? And that's why every single term in the equation is going to have some uncertainty associated with it, because you can only calculate the equation for the sample that you have in front of you. But what you want to do is you actually want to predict the population parameters from that equation. And that's why you will have some kind of uncertainty or some kind of confidence interval associated with every single term of that equation. Same is true for decision trees. Now, when you want to find some estimate for population parameters with such equations, this is where data validation comes into picture. And we'll talk about data validation in some other episodes. But what you have in supervised machine learning methods is you have a training data. With that training data, you train your model. Now, keep in mind that this model is trained on a sample training data. And then you have validation data with which you can going to make the estimation as certain as possible for the population with the validation data. And then what kind of validations we could do with this model and validation data is something that we will talk in another episode. And then you have test data, where you are going to test your model on that data. But then test data is basically an unknown sample space where you will apply the equation to the test data and predict the future. So basically, all we need to understand in data science is you are always working with a sample, but you are always interested in population. You calculate the sample statistics, but you estimate the population parameters. And you always want to estimate the population parameters no matter what. Whatever you can do to make the population parameters with as much confidence level as possible, that's what you do in data science. Thank you. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.